Located near Kelowna in southern British Columbia, Myra Bellevue Provincial Park preserves a dramatic section of the abandoned Kettle Valley Railway line. The KVR connected Midway in the Boundary Mining District to the Canadian Pacific Main Line at Hope in the Fraser Valley. Leaving the Kettle River, it contoured around the north end of the Okanagan Highlands. At Myra, it's at its highest elevation, 900 meters above Okanagan Lake. In 2002, the Myra section of the railway was declared a National Historic Site. But in 2003, fire on Okanagan Mountain destroyed 239 homes in Kelowna and 12 of the 18 Myra trestles. Commitment by the BC government, donation from corporate sponsors, and a huge volunteer effort rebuilt the trestles. The level grade makes a 12-kilometer trip between the locations of the Myra and Ruth stations an easy trip on foot or by bicycle. Today we'll start at Myra, but there's ample parking at either end. Myra Forest Service Road turns south off McCullough Road. The road is gravel, but generally well graded. At the turn, if you look north, there's a view of Layer Cake Mountain. Now I'll overlay the topographic map of the area. The contour interval is 20 meters. To the south of the canyon, the ground continues to rise up to Little White Mountain. To avoid unnecessary climbing, the rail bed clings to the canyon walls, utilizing 18 trestles, 2 tunnels, and a number of rock cuts. Now let's go for a ride and enjoy the scenery and some rocks along Myra Canyon. Okanagan Geology, edited by Murray Rowett and John Greeno, includes a chapter on Myra Canyon geology written by Brian Hughes. About 500 meters after leaving the parking lot, we encounter the first rock cut, steep and black lava. Around the bend at the level of the rail bed, the rock changes to red. Here's a geology map of the area. The arrow indicates our position. The sky blue colored map area is gneiss, a metamorphic rock formed at great depth. The gneiss was uplifted during rifting in the Okanagan about 50 million years ago. The tan patches on the map is our lava, identified as King Edward Creek basalt. This lava flow occurred sometime in the last 10 million years and is related to lavas close to Vernon. During the interval between uplift and lava flow, the gneiss was exposed and extensively weathered. Oxidation of minerals containing iron contribute to the red stain on this old topography. Where the lava cover was not ripped away by erosion, that old weathering surface was protected. The lava is dense with few visible crystals. At the base of the flow, the rock contains many holes. This is scoria. The holes are left by bubbles of gas or steam which could not escape before the lava solidified. The holes are called vesicles. You may find some that have filled with secondary minerals, such as quartz left by percolating groundwater. Below the lava and above the gneiss is a white or pinkish fine-grained layer. Is this a bleached soil horizon on the old weathering surface? Or perhaps it's tough volcanic ash? Does the scoria at the base of the flow indicate that the initial phase of the eruption was explosive? Before we move on, let's look back at the scenery, the lava cliff above, and the gneiss at the base. Leaving the first lava outcrop, we enter a deep rock cut through unweathered and very solid gneiss. Throughout the next 3 kilometers, all the rock will pass is gneiss. After a kilometer, we start to encounter the trestles. They are counted from the west, so the first we see is number 18. Of the roughly 12 kilometers between Myra and Ruth, almost 1.4 kilometers is on trestles. Originally, these had neither decking or guardrails, so earlier bicyclers had to be bold. At trestle 16, you can see a good example of banding in the gneiss. This layering is the result of recrystallization and separation of the minerals in response to pressure and heat. Just past the 2-kilometer mark and trestle 12 comes the first tunnel, slightly curved. It's 114 meters in length. reach the second tunnel, this one 84 meters long. Thank you.
Oh, well, that's a win.
Vessel 10. After Trestle 9, at about the 4-kilometer point, the cliff above is once again lava. As lava cools and solidifies, it contracts, resulting in vertical jointing. When undermined by erosion, these columns are easily dislodged and tumble down as broken blocks. Nearing the 5-kilometer marker, the rail bed swings away from the cliff and is separated from it by an overgrown berm of lava blocks. Here's another look at the geology map. We're now in position below another large patch of lava. Stop when you can see the 5-kilometer marker. The mossy and dirty rock immediately adjacent to the rail bed is gneiss. Then walk back along the berm for a better look through the trees at what's above. The gneiss is overlain by sand and large boulders of an ancient stream. The lava covered and preserved the stream channel. It's extremely loose and kind of dangerous to go up. Once uncovered, it erodes rapidly and undermines the lava, hence the berm, designed to trap rockfall. The lava here also has a light-colored and fine-grained material at its base. It's at least half a meter in thickness here. Trestle 6 crosses the canyon with an elegant curve. It's the longest and highest of the Myra trestles. Trestle 3 has good views east to the trestles we crossed earlier. Any day is a good day to enjoy the canyon, its scenery, its history, or geology.